So what do a 9-year-old handwritten diary entry, a $20 billion pile of silicon, and a secretive new Chinese railway all have in common?
Well, I mean, they are all about to completely fracture the global artificial intelligence ecosystem as we know it.
Exactly. Welcome to today's deep dive. We are opening up Aaron Rose's Tech Reader AI Digest for Monday, April 20th, 2026.
And there is a lot to get through today.
Yeah, our mission here is to just cut straight through the daily noise.
Yeah.
Look past the model updates and parameter counts and really examine the massive foundational shifts happening right now beneath the surface.
Right, the stuff that actually moves the needle.
Exactly. We're looking at these staggering multi-billion-dollar hardware bets, the legal ghosts that are threatening the biggest players in the space, and how the global map of AI power is quietly being redrawn.
Because, the through line connecting all of these seemingly disconnected events is just the sheer cost and control of compute. We're watching the entire industry realize that building the smartest frontier model, that's no longer the end game. I mean, that is essentially table stakes now.
Right. Everyone has a smart model.
Exactly. The new game, the one that will actually determine who survives the next decade, is about who has the fastest, legally unburdened, and most cost-effective infrastructure.
The plumbing.
The plumbing. If you are a developer pushing code, or an investor allocating capital, or just someone fascinated by AI, you have to understand this underlying plumbing.
Because it's dictating every major business decision in Silicon Valley right now.
Spot on. The rules of the game are shifting.
And honestly, nothing illustrates that sheer scale of capital better than what OpenAI did over the weekend.
Oh, man. Yeah.
They announced this dramatically expanded partnership with the chip startup Cerebras Systems. And it is a $20 billion commitment over 3 years.
Which is just a staggering amount of money.
It's wild. That number alone is double the figure that was floating around back in January. Plus, they're throwing in another $1 billion specifically for data center construction.
Yeah, and the digest notes that as OpenAI spending hits that $30 billion threshold, they actually receive warrants for up to a 10% equity stake in Cerebras.
Right, and just to complicate the governance optics a bit.
As always.
Yeah, as always. Cerebras has a mid-May NASDAQ listing approaching, and Sam Altman happens to be a personal early investor.
Right. But, $20 billion directed at a single startup's hardware, that is a tectonic shift.
It really is.
It signals a fundamental pivot from training to inference. I mean, the industry spent the last 5 years obsessing over NVIDIA GPUs.
Because they're the gold standard, right?
Exactly. They are the gold standard for training. You feed mountains of data into an architecture to teach it how to think. But the actual business model of AI that doesn't run on training, it runs on inference.
Generating the response.
Generating the response when a user actually prompts the model.
Okay, let's unpack this, because this distinction is everything for the listener to understand.
Yeah, it's crucial.
Think of it like this. NVIDIA's training GPUs are like sending your AI to a very long, very expensive medical school.
I like that.
Right. But Cerebras's inference chips,
Yeah.
that is like putting that trained doctor in the ER, where they had to diagnose patients instantly under pressure.
That's a great way to look at it.
But I do want to push back on the hardware choice itself for a second.
Sure.
Because Cerebras is famous for wafer-scale engineering. Instead of taking a standard silicon wafer and slicing it up into dozens of individual normal-sized chips, they keep the entire dinner plate-sized wafer intact. It's just one massive processor.
At the whole wafer.
But historically, that approach comes with massive yield issues.
Yeah.
Like if one microscopic manufacturing flaw happens anywhere on that plate, it can compromise the whole unit.
It's a huge risk.
Add in the absolute nightmare of cooling a chip that large, and it seems like a wildly risky foundation. So how does OpenAI justify a $20 billion bet on a manufacturing paradigm that the rest of the industry has historically shied away from?
Well, what's fascinating here is how the specific demands of AI inference have completely altered that risk-reward calculus. You're absolutely correct about the historical challenges of yield and cooling.
It's been a known issue for years.
Yeah. However, Cerebras routes around those manufacturing flaws with built-in redundancy at the microscopic level. But the real answer to your question is memory bandwidth.
Okay.
Traditional GPUs suffer from something called the von Neumann bottleneck. Basically, the memory where the data lives is physically separated from the processor where the math happens.
Right. So it has to travel.
Exactly. To generate just a single word, An AI model has to ferry massive amounts of data back and forth across that tiny physical gap. And for batch size 1 inference, meaning a single user, having a real-time conversation with the AI, that ferrying process is the ultimate speed limit.
It slows everything down.
It does. But Cerebras puts the memory and the compute on the exact same continuous piece of silicon.
So the data never actually has to leave the chip. It just moves instantly across the wafer.
Precisely. And that architectural choice is why the digest reports these chips can serve 3,000 tokens per second for reasoning models.
3,000 tokens a second.
Yeah. Which is roughly 100 times faster than the average human reads.
That is just incomprehensible speed.
Yeah.
And it matters so much because when you're running a modern reasoning model, an AI that actively explores multiple paths and plans and corrects its own logic before it answers you, that process is incredibly heavy.
Oh, very heavy.
On traditional hardware, you, as the user, just sit there watching a loading animation while the model quote-unquote thinks.
We've all stared at that progress bar.
Exactly. But at 3,000 tokens per second, that heavy multi-step reasoning loop executes in the blink of an eye. The friction of latency basically drops to zero.
And that changes the entire interaction paradigm. It stops feeling like you're submitting a query to a remote server and starts feeling like you have a localized, hyper-intelligent entity operating right at the speed of your own thought.
Yeah. And strategically, OpenAI is using this to build a massive moat ahead of their IPO.
Absolutely.
By taking an equity stake and locking down $20 billion in capacity, they're trying to ensure no one else can match their latency. Or their inference costs, for that matter.
They want to own the physics of the response.
Exactly.
They're systematically reducing their dependency on NVIDIA. Because whoever serves user queries at the lowest latency at the absolute cheapest compute cost per token, well, they capture the enterprise market. OpenAI is treating this infrastructure as a core strategic asset, not just some vendor relationship.
But, funding a $20 billion hardware habit requires an ocean of commercial capital.
It really does.
And the pursuit of that exact commercial capital is what triggered an anvil from OpenAI's past that is about to drop right in the middle of their IPO ambitions.
The lawsuits.
Yes. Jury selection begins in exactly 7 days. Next Monday, April 27th, in Oakland Federal Court, before Judge Yvonne Gonzalez-Rogers.
This is a big one.
Elon Musk is taking OpenAI to trial. He's seeking $134 billion in damages.
Wow.
Yeah, and he wants that money directed to the nonprofit arm. On top of that, he is demanding the removal of Sam Altman and Greg Brockman.
Right.
Now, before we analyze the evidence in Aaron Rose's digest, we need to set the ground rules for this discussion with you, the listener.
Yes, very important.
We are not taking sides in this billionaire legal dispute. We are not here to act as moral arbiters or declare who is right or who is wrong.
No, absolutely not.
Our job today is strictly to impartially analyze the evidence highlighted in the Tech Digest and explain what it means for the mechanics of this unprecedented trial.
That is a vital boundary to set. We're analyzing the legal architecture of a corporate dispute. We're examining how a 501c3 nonprofit transitions into a capped profit entity and the legal liabilities attached to that metamorphosis.
Right. And here's where it gets really interesting.
Okay.
The digest points to what might be the defining piece of evidence in this trial. It is a handwritten diary entry from OpenAI President Greg Brockman, dated all the way back in 2017.
9 years ago.
9 years ago. And in this private journal, Brockman wrote that if the company converted to a B Corp structure without Musk's knowledge, it was a lie, and that doing so would be pretty morally bankrupt.
Those are heavy words.
They are.
Yeah.
But I have to play devil's advocate here. As someone who writes down half-baked ideas and worst-case scenarios in notebooks all the time, a private diary is often just a space to vent.
Sure.
So how does a scribbled note from 2017, which was 2 full years before the capped profit subsidiary was even formed, and years before the $13 billion Microsoft partnership, how does that become the center of gravity for a $134 billion lawsuit today?
Well, if we connect this to the bigger picture, it really comes down to the immensely high legal bar required to prove fraud. Musk's legal team isn't just arguing that OpenAI changed its business model. They're arguing that the transition away from a pure open source nonprofit was a fraudulent bait and switch from the start.
Oh, wow.
Yeah. In corporate litigation, defense teams usually rely on the business judgment rule. That's the idea that executives made reasonable decisions as market conditions changed.
Right.
So the defense narrative is that as the compute costs required to train these frontier models skyrocketed, the pure nonprofit structure simply couldn't attract the capital needed to survive. So they evolved.
They evolved out of necessity, just to keep the mission alive.
That is the defense. But to pierce that defense and actually prove fraud, the plaintiff must prove contemporaneous intent.
Contemporaneous intent.
Yes.
No.
You have to prove that the executives knew they were being deceptive at the exact moment the decisions were being made.
Yeah.
And that is why Judge Gonzalez-Rogers explicitly cited this 2017 diary entry when she denied OpenAI's motion to dismiss.
Because it shows the mindset.
Exactly. A 9-year-old internal document written by a key executive, acknowledging that moving away from the nonprofit structure behind a co-founder's back would be a lie? Well, that completely disrupts the narrative of a natural good faith corporate evolution.
It provides the intent. And, what makes this so volatile is that this isn't a bench trial where a judge decides the outcome based on some dry corporate statute.
Yeah, it's a jury trial.
This is going to a jury. You have 12 everyday people in Oakland sitting in a box, and they are tasked with untangling fiduciary duties and complex AI corporate structures.
Which is incredibly difficult.
It is. Abstract legal theories might lose a jury entirely. But a handwritten note from a company president using the words morally bankrupt, that is deeply human, visceral evidence.
It really is.
It takes this dizzyingly complex $134 billion dispute and grounds it in a very simple, relatable question of honesty.
And it creates an incredibly steep hill for the defense to climb. I mean, the burden will be on OpenAI's legal team to contextualize that diary entry for 12 laypeople, basically explaining away those specific words while their current valuation sits in the stratosphere.
It is going to be a grueling 4 weeks in Oakland, that's for sure.
Unquestionably.
But while the American AI giants are tangled up in federal courtrooms and pouring billions into U.S. hardware ecosystems to break the NVIDIA bottleneck, there is a completely parallel, highly coordinated AI universe accelerating on the other side of the planet.
China.
Yes. The digest highlights 2 massive infrastructure moves in the Chinese ecosystem. First, Alibaba dropped a preview of its flagship model, Qwen 3.6 Max, on their Balian platform.
And the specs are impressive.
Very. It boasts a 1 million token context window, which fully matches the frontier standards of Western models like Claude and Gemini.
Right.
Crucially, Alibaba is teasing a mysterious Hello World consumer product launch for this Wednesday, April 22nd.
That's interesting phrasing.
It is. Meanwhile, DeepSeek has actually delayed their highly anticipated V4 model. But they delayed it to optimize the model specifically for the Huawei Ascend 950PR chip.
Which is a massive detail.
So what does this all mean? Like, if AI runs on hardware, NVIDIA has essentially laid the railroad tracks for the entire world. Everyone builds their software to fit the specific gauge of NVIDIA's tracks.
Yep.
Bypassing NVIDIA to use Huawei chips is like a country deciding to rip up those tracks and lay an entirely new railway system with a completely different gauge of track.
Wow.
They're doing it so their domestic trains never have to rely on imported, embargo-restricted tracks again.
Well, this raises an important question regarding the deep software lock-in that defines the current market. But let's unpack the Alibaba tease first.
Okay.
A Hello World launch accompanying a model with a 1 million token context window. In developer culture, that phrase deliberately signals the birth of something entirely new. It suggests they are rolling out an entirely new consumer ecosystem, likely deeply integrated into Alibaba's existing mobile and commerce dominance.
Right.
They are operating on a sovereign development cadence. They are completely unbothered by the product cycles of Google or OpenAI.
But I want to zero in on the DeepSeek delay, because leaving the NVIDIA ecosystem is notoriously brutal for developers.
Oh, it's painful.
I hear constantly that NVIDIA's real moat isn't even the physical silicon, it's CUDA.
Yes.
CUDA is the software layer NVIDIA spent 15 years building that allows developers to easily communicate with the GPU.
It's the industry standard.
Right. So if DeepSeek is abandoning CUDA to write directly for Huawei's architecture, they're taking on an agonizing amount of software engineering. They literally have to rewrite the fundamental math libraries that make AI models work.
The kernel rewrite is the ultimate friction point. It really is. For a lab the size of DeepSeek to willingly absorb the pain of a delayed launch just to map their architecture to the Huawei Ascend 950PR, well, that tells us 2 things.
Okay, where are we?
First, it acknowledges the reality of U.S. export controls. They know they cannot rely on a steady supply of high-end NVIDIA silicon.
Right, they have to adapt.
Second, and more importantly, it proves they actually believe the Huawei hardware is capable enough to warrant that massive software investment.
That's a huge vote of confidence in Huawei.
It is. They're building a sovereign Chinese AI stack from the raw silicon all the way up to the frontier model application layer. If they can pull off the software optimization, the hardware fab gap, the fact that Huawei doesn't have access to the latest TSMC manufacturing nodes, that starts to matter a lot less.
It's basically a pursuit of total infrastructural autonomy.
Exactly.
But, we've spent a lot of time analyzing $20 billion deals, billion-dollar lawsuits, and nation-state level hardware stacks.
A lot of high-level stuff.
Yeah. Let's bring this all the way down to the ground level. What does this friction look like for you, the person listening, who is actually trying to build products with these tools today?
Right. What's the practical impact?
Because there's a massive hidden cost to all of this friction. The digest features a quick hit that perfectly illustrates this downstream impact. Anthropic's Claude Opus 4.7 is rolling out on GitHub Copilot.
Which developers have been begging for.
Yes. Having a frontier reasoning model integrated directly into your coding environment is the dream. But it comes with a punishing 7.5x premium request multiplier.
7.5.
A 7.5 times multiplier. I really want to champion the perspective of the developer here because this is what I call the developer tax, and it fundamentally breaks the promise of the technology.
How so?
Well, we are constantly sold on this incredible future of agentic workflows, right? Where you give the AI a high-level goal, and it spins up a dozen sub-agents to write the code, test it, debug the errors, and iterate in a continuous loop.
Yeah, full autonomy.
But an agentic loop requires thousands of background API calls. If every single one of those automated requests costs 7.5 times more than a standard query, you hit a financial wall immediately.
Instantly.
You might engineer the most brilliant autonomous workflow in the world, but if running it bankrupts your startup's monthly compute budget in 3 days, the tool is useless.
The economics of inference simply do not scale linearly with the ambition of the software. And this 7.5x developer tax brings our entire discussion today full circle.
It does.
The reason Claude Opus 4.7 is so expensive to run is the exact same reason OpenAI is committing $20 billion to Cerebras. These frontier reasoning models are simply too heavy to run efficiently on traditional hardware architectures.
So if the compute cost doesn't come down, the ecosystem stalls.
It stalls completely. If independent developers and enterprise IT departments cannot afford to execute agentic loops at scale, then all of this model intelligence just remains trapped behind a velvet rope.
It is inaccessible.
Right. The software layer is ready for mass autonomy, but the physical infrastructure is bottlenecking the revolution. That is exactly why the hardware bets are dwarfing the software investments right now. The race isn't just to build a smarter artificial brain anymore.
No.
The race is to invent a cheaper way to power it.
What an incredible interconnected landscape to take in. Let's do a quick recap of the massive scope we've covered today.
Sounds good.
We started by looking at the staggering physical requirements of speed. OpenAI committing $20 billion to Cerebras to leverage wafer-scale chips, bypassing memory bottlenecks to hit 3,000 tokens per second.
Incredible speed.
Then we examined how the pursuit of the capital needed to buy that hardware triggered an existential legal threat. A 2017 diary entry haunting OpenAI's boardroom as they faced a $134 billion fraud trial in Oakland.
With a jury.
With a jury. From there, we mapped the geopolitical fallout, watching China willingly endure software delays to build a sovereign silicon stack entirely isolated from NVIDIA.
Right.
And finally, we brought it right back to your laptop, looking at the 7.5x developer tax that proves why breaking the cost of compute is the single most important hurdle in tech right now.
It really is.
I want to thank you for taking this journey with us. When you take the time to look past the superficial benchmark scores and understand these foundational layers, the hardware architectures, the legal precedents, the global supply chains, the daily barrage of AI news, suddenly makes perfect sense.
It truly provides the necessary lens to filter all that noise.
Right.
But, I want to leave you with one final provocative thought to mull over based on everything we've unpacked today.
Ooh, lay it on me.
Well, if American AI giants become completely reliant on bespoke, specialized chips like Cerebras,
Okay.
and China successfully builds its own isolated hardware stack on Huawei silicon, to completely bypass NVIDIA, are we heading toward a hardware-enforced splinter net of AI?
A splitter net.
Yeah.
Wow.
Like, will the actual capabilities, the logical reasoning, and fundamentally the worldview of an AI soon depend entirely on the physical constraints of the silicon it was trained on and the country where that silicon was manufactured?
Man, the idea of nationalized hardware dictating the mind of the machine is a wild concept to end on. Keep questioning the sources, keep looking beneath the surface, and we will catch you on the next deep dive.